Hello, everyone. I think we're ready to start now. We're happy to have you all here today for our CLion Ask Me Anything session. So let me first briefly introduce the team who are with you today. So we have Dmitry Kozhavnikov, and our CLion team lead, and Ivan Donchevsky, CLion software developer who are responsible for C++ support and C++ language engines and IDE performance tuning. Semyon Kalton, software developer responsible for project models. Ildar Abusalimov, software developer responsible for the debugger part. Vasily Romanikhin, software developer responsible for remote development. Ilya Motorny, software developer responsible for embedded development. Alexey Utkin, software developer responsible for unit testing, formatter, and some more language stuff. And me, Anastasia Kazakova, C++ Tools product marketing manager. I will be moderating the session today, and Phil Nash, our developer advocate, will help me today as well. So we've collected quite many questions via the registration form, and we'll also handle the questions online. So we suggest we go by subsystems in the following order. So we'll start with the language support. We'll share our plans on C++20, on other static analyzers integrations, and so on. Then we'll go through the performance tips, project models, debugger support, remote development, including Docker and development for Raspberry Pi, embedded development and some Arduino topics, and all other questions that we'll have. So for example, if you ask a question on debugger related topics, so we'll handle it during the corresponding debugger part. So all questions which do not fit into these sections will go to others, and we'll also follow up via email with any questions left unanswered. And also, I would like to share the exciting news that in the end of April, we've launched Rider for Unreal Engine public preview. So it's actually an addition of our Rider cross-platform .NET IDE, but with the C++ support on board and especially focused on Unreal Engine development. So if you're interested in Unreal Engine development, you might be interested in grabbing this thing and giving it a try. And so now we're ready to start. We'll start with the C++ support part. And the first bunch of questions dedicated to the C++ support, and we'll probably start with the state of the C++ language engines in CLion. You probably know there is more than one now. And I would like Dmitry Kozhavnikov to address the state of art and share the news about the evolution of the language engines. So Dima?
Hi, everyone. So my name is Dmitry, and yeah, I'm probably not going to answer on some specific question here, so I'll be talking for a minute about just the state of the language support in CLion. So basically, yeah, we have our existing parser and language support in CLion written in Java that exists for several years now. And also, as you might notice, we have a CLion like an engine based on Clang. We called it like CLion engine. So what's the difference? Why we have two of them? CLion works well for basically for a single file, for all the features that can be executed on a single file open in the editor. That's like error, syntax highlightings, completion, and so on. So we moved a lot of important features to that, and it worked great because it's actually 100% correct. It's using the modern compiler front end, and we are most happy with it. However, we for now we can't move to CLion fully because still the performance for the project-wide operations for indexing, like providing you information to for refactorings and for find usages and for go to symbol stuff is still not very fast, and our existing engine is actually several times faster, and on some projects it's like 10 times faster than just CLion, because CLion basically works at the speed of the project build. So that's basically it, and for now we're going with two engines, and they complement each other, so you basically see proper errors and nice index highlightings and local code completion from CLion. But when you invoke find usages or when you like wait for the initial indexing, in general it should happen way faster than building the project with the compiler. So yeah, that's basically it about CLion.
Yeah, thank you, Dima. And now maybe you could share how we work with the preprocessor code and do some demo. So I'll make you a presenter. Yes, we can see your screen.
Yeah. So, and now I must answer a specific question that was sent beforehand. So basically the question is, if I have the following structure that basically in some file a user has two conditional includes based on platform. So obviously one of it is actual for the current platform, and one of it is not. So what do we do in this case? And yeah, so the user says that this doesn't work for them in CLion. So if it doesn't, please drop us an email in our support, or just in any way maybe a ticket in our tracker, because for me it works. And I use this chance to speak a bit about how, what do we need to do for IDE and how the preprocessors handled and so on. So as you can see, here is the main.cpp file, which is actually a proper file added in CMakeList.txt, and it's a file visible by the compiler as a source file, and it's compiled. And here are the includes, and please note that these files are not added to CMakeList.txt, and these are just includes. However, just doing textual include by the IDE is not acceptable for the performance, because, for example, our stream expands into several tens of thousand lines of code. So we're doing a bunch of optimizations to handle that. Nevertheless, as you can see here, I'm on Windows, so one of the branches is active. You can go to the active branch, and as you can see, the file here is not standalone. It requires the stuff from main CPP to be properly compiled. However, the CLion actually works correctly in this case. So you can go to definition of foo. You can show see parameter names, show parameter info, foo, and stuff like that. And yeah, and you also can go to the actual definition from the usage. So yeah, the important thing I want to note on these questions about this question. So if you actually specify these files like in your project model, for example, in UC Makefiles and so on, yeah, that's basically wouldn't work. I can't write here like module windows.cpp here, but the project also doesn't compile. So yeah, and I also see a question in the question that the back reference to foo, yes, indeed, it based on on a selected context. For unfortunately, I can't change it now because I only have like Windows context here, and yeah, but you can go to declarations and use this on foo, and it actually works properly on the currently selected context, like that I'm on Windows, and you can see that this define is actually defined, and yeah, this preprocessor branch is active.
Yeah, thank you, Dima. Maybe you can also address some other questions I see now online. First of all is about the CUDA support, and like in terms of the framework, the language support, the UI designer, the QML support. Maybe you can say a few words on our plans here.
Yeah, so sure I can, and also a bit about plans too. So first of all, it's totally possible to develop CUDA applications in CLion, because CUDA applications are just normal C++ applications. So if you build everything with CMake, everything should work out of the box. Indeed, we lack some CUDA specific support. We lack integration with CUDA designer, and we also lack some features specific for CUDA framework, and basically the answer to that is that we don't have any immediate plans to support these custom integrations for specific frameworks right now, because yeah, like in either world, we'd like to avoid doing that ourselves, because we believe that these kinds of integrations are better maintained by the community and by people that actually use these frameworks. So we like to concentrate mostly of language specifics, like core language stuff. However, the request about CUDA is especially popular, so we actually considering doing a bit of integrations specifically for CUDA, maybe later this year or next year. Yeah, so it's about like integrations, and we don't want to make a UI designer from scratch by ourselves, because we believe that the specialized designer from Qt is we can't catch up with the features, but yeah, we'll consider it, but it's not in our immediate plans. And about QMake, there is a question about QMake. So I think we'll leave it until the project model part, but yeah, let's come back to QMake a bit later.
Okay, thank you. Yeah, another specific question is about committing .ide files to the repository. So like the user asked, I've complaints from tech leads that my project had .ide files committed. So what is the best way to set up our CLion project so this folder does not need to be committed?
So basically, we have some, well, to have the full CLion experience, so it would save your per project settings and it would share your per project settings with your colleagues. You need to commit your .ide file and .ide folder and some files from it. We have a guide online which files to commit and which files are designed to be local, but some files are expected to be committed. However, if you're actually the only one using CLion in your team and you don't want to share like your IDE specific files, it's totally fine to just keep it in your gitignore, just add it completely in your gitignore, add .ide file completely in gitignore, and what you lose is you're not be able to use like predefined CLion settings for your projects on every machine you clone it, but basically you can work with it.
Okay, thank you. There was also a question, maybe not very specific, about what's the timeline to get CLion Match IntelliJ features for code editing. There is no more specific about that, so maybe you can just share our plans on getting more intelligent features into CLion.
Well, first of all, like language support and code editing features in IntelliJ IDE is basically our goal. Is basically our gold standard about for the language support. However, as you probably can notice, the Java is like a language specifically designed for good IDE support. It's very explicit and very verbose. It's kind of simple, and it's much more complicated to get this level of IDE support for C++. So it's basically our moving goal. We're aiming at this level of support, and for the speaking about the recent future, we basically decided to allocate the next iteration before the 2020.2 release more to quality and performance fixes and memory usage fixes, if speaking specifically from the language support side. So you probably should not expect that much of a new bright features in 2020.2, but we will return back to features and hopefully do something cool in the future releases.
Okay, thank you. I also see some questions back to Qt, actually about the QML support. So I've already responded that there is a QML plugin, but the question is if we plan to do something officially in that way, in that direction.
Yeah, again, there are no like immediate plans for this release, but the way we work is that we always listen to feedback. So, for example, this kind of event and the amount of Qt questions we have, it's also important to see. So we're constantly adjusting our targets, and yeah, as I said, we probably want to we probably will have some additional Qt integrations in the future. We have some QML support, QML plugin in our plugin repository, but I'm not sure if it's basically third party, like the outer works at JetBrains, but in different departments. So it can be treated as third party, and it's not very active maintained. Maybe we will take over it someday, but yeah.
Okay. Yeah, thank you, Dima. So the next question is actually from the registration form is one CLion is going to support the C++ core guidelines, and also maybe here you can also add some information about how to add support for some custom static analyzers to CLion. So could you please?
Yeah, okay, so basically in CLion we integrate clunked ID support. Clunked ID is well, is a framework and a bunch of checks for various C++ like code style checks and so on. So clunked ID comes with a bunch of core guidelines checks. I think they're disabled by default because all of them are opinionated, and you get a lot of false positives. Just open the current project with these checks enabled. Still, you can go to CLion settings and go to inspections, find clunked ID there, and then there are a bunch of checks that enabled or disabled. So, for example, there is a check that calls avoid C arrays, and this is the core guidelines check. And yeah, if we do that, and then hopefully, as you can guess, it's a live demo, so everything would go wrong, but I'll try. So yeah, basically, as you can see, clunked IDs says that do not declare C-style arrays, use std array instead, and it unfortunately does have a quick fix, but yeah, here is a check. You can just inspect it or suppress it or disable or stuff like that. Yeah. So
Okay, thank you.
Yeah.
Yeah, please proceed.
Yeah, there was a question also about like general code static analyzers. Yeah, so basically Science CLion lives on IntelliJ platform, and it shares the same plugin API to integrate like code analysis in editor and stuff like that. So it's possible to integrate an arbitrary third-party code analyzers via plugin, and we also have a for example, we have a CPP check plugin and I believe CPP lint plugin, all of them maintained by third-party developers. So you can search via plugin marketplace. So there is a CPP check plugin. So you can install it and get your CPP check in your editor. Yeah, and we also have plans about integrating more static analyzers, or maybe helping. We are in talks with some developers to help integrate their products. So yeah, that basically works with the IntelliJ plugin infrastructure and IntelliJ plugin APIs. Yeah, that's it.
Okay, thank you. Maybe now you can just, before we jump to next part, you can briefly share our plans for C++20 support.
Yeah, actually, we've agreed that also Ivan would answer some of the questions, but I'm taking all to myself. Maybe Ivan would like to jump in.
Yeah, Vanya, would you like?
Okay, no problem. As for C++20, we continuously get latest CLion from master. So it happens usually once in about 2 weeks. And that means we get most up-to-date C++ support, which is available in CLion. So sometimes even a bit earlier than it appears in official release.
Okay,
that's more or less it.
Yeah, thank you very much, Ivan. And now maybe the last question on C++ support, but will be about the C++ standardization and our participating in the C++ committee meeting. And maybe Phil, can you address it here?
Hi, yeah, so there's a couple of us that do go to standards meetings. We did that for slightly different reasons. One reason is that obviously we as tool vendors want to participate in the standardization process, and I think that's what the question was mostly getting at. So that primarily revolves around the study group SG15, which is set up specifically for tooling. And when that was first announced, that we were quite excited about that. That was going to be our voice in the committee, and to some extent that's true. But for now, they're focusing more on build systems and packaging systems, which is all great and related, of course. But for now, we don't have a strong voice in that. So I think Dimitri, who you just heard from, has been participating more in the tooling discussions with them. And I've been keeping half an eye on it. Me personally, I tend to go more just out of general interest. There's a few language features that I have a particular interest in, like error handling, pattern matching, that sort of thing. So I've been following that more, and I tend to go to every other standards meeting and follow some of the discussions online. That's not really anything specific to JetBrains. It's just really a way for us to just keep tabs on what's going on, really. So I think the tooling thing is probably the most direct link that we have with the committee. The other thing we do is we do make sure that all of the committee members actually have access to free licenses for CLion, so they can actually give us feedback directly, right at the cutting edge of C++. So that's a way that community can feedback to us.
Okay, thank you very much, Phil. And I think now we should switch to the next topic, which is kind of interesting to our users. It's their performance tips. So Dima, can you maybe address our plans and share a few tips on the tuning the CLion performance?
Yeah, so first of all, first I want to acknowledge that indeed CLion has some issues with both like UI freeze and CPU usage on some projects, on bigger projects, and I want to thank everyone who patiently helps us investigating some specific issues, because there is no like one single issue that for CLion, but it's very project dependent and it's very environment dependent. So thank you everyone who's sending us logs and snapshots and collaborating with us on it. And yeah, so performance work is our number one priority in the language support part. And yeah, since while we have a long road to go, we receive a lot of feedback that there are notable fixes for some projects and for some people. That's we are glad to hear that. And for specific plans, we have some major reworks that in progress that I won't be disclosing because most of them are high risk, so they might fail. But as well as that, we're just doing a lot of fixes every release, and yeah, we're improving in how we handle performance issues, how we test for them, and how we fix them. So a bunch of fixes for CPU usage and for free is also coming to the next 2020.2 early access program, which is a beta program that opens in about a month. So we would really appreciate if you use it and see it if it helps you, if you have any issues. So yeah, that's like the general. That's the
Yeah, and I
general
think
story.
we can recommend this link to everyone who are looking for some performance tips. I can try and switch to this page to show you what you can find here, and you can briefly describe what's the value people can find here.
Yeah, so basically one of the most annoying issues is that since CLion is based on the IntelliJ platform, it's a Java application, and Java has this annoying this annoying thing that it can't get more memory from operating systems that you give it initially, and also, but insufficient amount of memory may cause performance issues. So there are ways to increase the top limit of memory. It's not so if you have additional memory, you can give it to CLion and work. It should work better. Yeah, so basically this link describes how to do that. And also there are a bunch of specific tips about what are the most common violators which can be turned off as a workaround to help with performance issues. And also please note we are working on all of them. So some of the fixes for them came to 2020.1 and some fixes are coming for 2020.2, but yeah. And also there is some tips how to speed up indexing and building symbols. For example, if you have some auto-generated directories that you don't use, you don't navigate to that, you can exclude it from indexing, and they still should be properly read if they are directly included in your files, but they won't participate like in go to symbols and other indexing activities. Yeah, and also if you're ready to have some CLion specific code in your project, it also might help a lot. So if you have some especially complicated language constructs, you can shield it from the IDE and just provide some dummy placeholders for the IDE. I totally understand that it's sometimes it's not an option, especially if, in a project shared with others, but sometimes it can help. Yeah. And also there is a link to instructions how to report performance issues. So again, thank you everyone who reporting the issues to us. It's very important to us, and it helps us dealing with it faster and more efficient. So that's it. Thank you.
Yeah, thank you very much, Timo. And now we're coming to our next part, which is project model. And I guess everyone is expecting some Makefiles prototype demo. So Sam, let's just jump directly into it.
Okay, let me just jump into demo. So I'll be showing CPython project that uses AutoTools and Makefiles. So this is just a clean project that I simply configured with configure script and with default settings. So let me just go into CLion. You should notice that this is actually an internal build, so it is not currently available to users, but it will soon be. So I just go to Open or Import and select CPython Makefile. Just click on it, say Open as project, and as you can see, CLion opens it. And here you can see the process that CLion is actually importing it into as project model. So it will take some time, so let me explain what's going on. Basically, CLion just executed make with just basic options with option just print and print directory. This forces make to print output log without any execution and actual build, and it just prints to the output. So we, after that, parse the output and try to extract compilation comments that make printed to the output. After that, we can just parse these comments and use them as info needed for our project model. So as you can see, importing finished and also indexing already finished. So now we can just go to project structure, and as you can see in object files, we imported a bunch of files. For example, this file ECCUC, I don't know what actually does, but it is parsed correctly, and we can use navigation in it. We can, for example, search for all usages for PyObject. As you can see, there are a lot of them. So I should probably cancel it right now. Yeah, that's basically how we import project model, and some nice tip. So since it's CPython project, there is a lot of Python code. If you want, you can just go into Python file, press configure Python, and select some Python interpreter, and then it will just scan index this, and soon you'll see that Python is correctly parsed. So also we provide for now only basic support for building and debugging Makefiles. For that, you can just go into settings, go to custom build targets. Soon it will be not here, but for now it's over here. You can configure some build target, say that you want to build here you specify make target. So for CPython there's target Python exe, and clean target, let's use just clean. So that's our custom build target, and as you can see, Python indexer finished. So yeah, everything works in Python. So yeah, we can go. We can parse Python. Yeah. So now we can, for returning to building and running, we configured build target. Now we can just create some some run configuration using build target. So now we press OK, build, and as you can see, building is started, and you can see building process over here. So it will take some time. So let me explain some problems that you probably expect to see. This is demo, so yeah, I prepared it so it works pretty well, but there are obviously some problems with how our Make support works, and the most pressing one is that actually, as you could see, we didn't execute make. We just full actual make build. We just executed just print and parsed output. This causes some trouble since some projects don't actually print as good output as CPython, and they can obfuscate output in a lot of ways. We try to use some heuristics to extract compilation commons, but for several projects it is just not possible, unfortunately. For example, currently it doesn't really work with Linux kernel, but there is some important rework in process right now that will enable Linux kernel being parsed correctly, and it hopefully will work by the time of release. So as you can see,
thank you, Simon. Yeah, maybe we can just maybe we can also add here, because there might be some confusion, that this is still not available to the public. This is just a prototype we're working on. So could you maybe share the plans when we're gonna make it public?
Yeah, we're planning to release public preview for this plugin soon. But hopefully by the time of the first YAP for 2022, and then hopefully it will be released as at least experimental plugin by the time of the actual release of 2020.2.
Yeah, thank you very much. So should we move to other build systems, or would you like to add anything else about the Makefiles here?
No, I think so. I can
move
just
on.
show that everything can be executed, but it's not that important.
Yeah, let's just show how it works.
So yeah, you just, I don't know.
Okay, so thank you for this demo. And now maybe you can say a few words about other build systems. So there were questions in the registration panel about the Meson support, about the Bazel support. So what are our plans? What are we going to do here? So is there any API available to add other build systems?
So right now there are no exact plans for no Meson nor Bazel support. We are looking into at least Bazel, and hopefully it will be supported at some time, but for now there are no exact plans. There is a plugin for Bazel supported by Google, but it's not very well done, so it doesn't work pretty well. For API, there is some API not public, but some users use, some people manage to use it. And the most useful for user from the user standpoint is CLion support for compilation database. So I also prepared some demo for compilation database. So let me just open. For example, for Meson, there is Meson automatically generates compilation database project. Not compilation database. It generates compilation database, so CLion can just open it, and I already prepared it, so I will not show the full process. But yeah, so you can see Meso project that is that uses Meson, and it works pretty well. You can see like sources parsed correctly and everything working correctly. So yeah, compilation database is your way to go if you want to import some project that is not natively supported by CLion.
Yeah, thank you very much, Sam. And I would like to add that, like, probably the main issue with Bazel plugin is that Google is kind of pioneer here. So they created a plugin for the project model, but there is no public API here. And so that's partially our fault that we break things in the plugin constantly with every release. So we still plan to maybe revise it and help Google to create a plugin that actually works and doesn't break, but that's still not the not the upcoming release, maybe a bit later. Yep, I think that's about the Bazel. Okay, so maybe you can handle also a few questions on CMake, so which we've got already. So one is about our plans for CMake documentation and IntelliSense. So can you say a few words about these features?
Well, right now they are not really supported fully, but there are several plugins in our plugin repository, both free and paid plugins that work pretty well. But hopefully, we will at some time we will implement it on ourselves in CLion natively. But for now, there are no plans.
Okay, another question is from the questions pane comment, and is there any way to disable CMake as I have to add the location of every executable in CMake lists? So not sure what was actually meant
probably
here.
The question is about being able to execute any file, not just CMake files, CMake executable target. And if that's the question, then you can, using CMake application run configuration, you can just select any executable and you will be able to execute, debug it, not necessarily the ones that came from CMake lists text, if that was the question.
Yeah, okay, thank you. And then we also have a question, is there any way to change the directory of program savings?
Yeah, there is an instruction. I can try to find link, but yeah, it's totally possible. You just need to specify some environment, some command line options for CLion, and it will store system configurations in whatever directory you need.
Okay, and maybe the last question on CMake is, can we customize the rules for auto-formatting the CMake files? And if we intend to use the CMake format tool instead of a built-in formatter. So maybe you can share, just show the CMake formatting settings.
Yeah, let me just. So yeah, in settings set the code style CMake, you can just specify whatever settings you want, and you can just disable it forever if you want.
Yeah, and I think it could be a nice feature request for the future to support CMake format tool, like as we support, for example, Clang format for formatting. So Alexei, what do you think about it? Do you think we can do that in the future?
There is no any obstacle on this way. Yes, we can.
Okay, cool. Probably the one who requested it need just to create a feature request for us. Okay, thank you. And the last question to Simeon regarding the project models, maybe like you've said a few words about some toolchains update and the settings update. Maybe you can share our plans on the toolchains rework here and what we plan to achieve here.
Yeah, we are planning the whole rework of toolchains panel and toolchain settings in CLion. So right now there is a problem that toolchains are very bound to CMake actually, and they're not extendable enough. But we are planning to rework it, allow adding any tool you need, specifying environment variables, root access, giving root access to toolchain for toolchains and so on. So we are planning it, and hopefully it will. This rework will start pretty soon, but I can't show. I can't say the exact time right now.
Okay. Thank you, Simon. Okay, so I think we're done with the project model part. I will take the screen from you now, Sam. So yeah, so now we're coming to the debugger part. So we'll start with the very short tips and tricks demo. So Ildar, be ready. I will share the screen with you now.
So here is my sample application. First, I'm gonna show you some very basic debugging features. So I'm pretty sure most of you already know this, but let's go through anyway. So this is a sample application that tells you a day of the week based on the entered date. So let's run it. So it asks us for some inputs, right? Let's enter. And yeah, it seems that it's not complete. Okay, let's try to figure out what's going on here. But first of all, if you notice, if we now debug it, it asks us to enter the date all over again, right? That's not convenient. So the very first thing that we are going to do before we start fixing it is create an input file so that we are not forced to do the manual input things each time we run it. So I prepared some files beforehand so that we don't spend some time here. And here's how you basically do it. You select the file from here, but I also created the necessary configurations. So let's run that. Okay. So now we run it and we see the output instantly. We don't have to switch context. Great. Let's put a breakpoint and be sure that we stop on it. So to do that, I use the toggle breakpoint action. It's it's usually command F8 or control F8. And so now we see that we stop that we stop when we hit the breakpoint. Great. So let's then try to fix it, the missing output. So obviously something's wrong here, and fingers crossed, I'm gonna do some live coding. Let's add some code here. Let it be switch. So CLion suggests to add some missing branches. Okay, so one of my favorite editor features here is the multi-cursor or multi-caret. So we can add some carets and write the code at once. So return, and we are gonna just copy this from here. So another great feature of the IDE is extending selection. So it's basically, it's not about debugger at all, but I use it a lot, so it's worth telling anyway. Okay, so let's add it here and it's not readable. Great. And rerun the code. Yeah. So it's worth saying that another great thing about the multi-caret is that you can also use toggling action here as well. So you just use toggle breakpoint and you set the breakpoints at once. So it's kind of nice, especially in case of the switch case statement. Great. So let's run it again. And we see that our run configuration, the selected run configuration using the input file corresponding to Thursday, actually stops suspense at Thursday. And that's great news. Let's proceed. So there are on the debug window, you can see the basic step-in actions, but I do encourage everyone to just use the hotkeys. So you usually see these tooltips and the corresponding hotkeys. So it's very easy to remember some basic hotkeys for stepping into or stepping over. So believe me, it's worth it. Okay, so now if we rerun it again, come here, and so here we used multiple breakpoints in order to stop on a certain case, but there is another way of doing it, is by using so-called conditional breakpoints. So we can toggle a breakpoint, then we are gonna invoke the contextual actions and use the edit breakpoints view to change the conditional. So let's make it stop only when it's Saturday, for example. So take Saturday. Great. Okay, let me rerun. So command F5. Great. So okay, so it's demo effect. It doesn't work as expected. I believe I haven't prayed to the demo gods today. Okay. Anyway, let's remove these line breakpoints. Maybe that's what interferes here. And run this once again. Okay, for some reason it doesn't respect the conditional, but I guess that's because of using enum. But anyway, okay, shit happens. Let's proceed. So here is actually more properties of breakpoint, some advanced features. It's worth knowing about this dialog because from time to time I do use some features listed here, but actually most of the time you'll find just using the condition and maybe the log message. So you can turn on suspending the execution when it reaches the breakpoint, and instead of that, so you see it turn yellow. Instead of that, a message is gonna be printed to the console saying that the breakpoint reached that particular place, but it didn't suspend yet. So I think it's basically it regarding the very basic demo. There was actually a nice question about stepping into the functions. I mean, not stepping, but rather not stepping into them. So whenever we I'm going to step into the code, the execution would jump into some std implementations. That's not desirable because you lose context and you're usually not interested in that. Actually, now I'm debugging using LLDB and it doesn't have this issue, so it's pretty much GDB specific. But that's not because GDB is worse than LLDB. It's all configurable, and actually the thing is, it's just LLDB has more reasonable defaults. So if we actually navigate to the LLDB console and disable some specific setting, we can reproduce this behavior here as well, just for sake of the demo. So let's say, if I remember correctly, it's process. Let's target. Let's target process threads. Yes, step avoid records. Yeah. Let's first show the current settings. So as you see, LLDB is configured to skip all the functions that start with student. So if we, for some reason, reset it to empty, we are now going to end up in some library code, which is not what we want usually. So let me, yeah, and it goes there again and again. Yeah. So in order to avoid doing that, in case of LDB, there is nothing to do. It's by default. But in case of GDB, there is, let me show, there is a specific settings called specific setting called skip, and you basically wanna add this line to either to the console, GDB console if you debugging using GDB, or add a so-called GDB init file. GDB init, and add this line here. So the next time you run your program with GDB, it's gonna use this setting to avoid stepping into this library code. And that's pretty much it. So maybe I'll now pass to Anastasia, who probably wants to
thank
ask
you.
some more
I'll
questions. Yeah.
grab your screen and we'll just continue some discussion on debugger. We
Yeah.
have a couple of more questions left around the debugger. One is about the CUDA debugger support and reverse debugging. Maybe I will briefly just address them and we'll pass to you on the next about the cross-language debug. So regarding the CUDA debugger, so you might have noticed that we've added CUDA language support in 2020.1, which definitely raised a question on CUDA debuggers. So we should mention here that CUDA debugger is kind of different from GDB and LDB in terms of integration. So we can't easily plug it in using our current API, but we are currently collaborating with the NVIDIA team and trying to find out what are these debuggers about, if we can easily integrate it. And so hopefully in some nearest future, we can have some kind of an integration. And regarding the reverse debugging, there is there are actually nothing built in, but there are a few options you can use, and one of it is the undo reverse debugging capabilities. So undo team actually has a plugin for CLion, which works nicely, and we had a blog post regarding the integration, which you can actually read through and see how it works. And also you can search through the blog for the recording of the webinar, which we've done together with the undo team, and learn how you can do the reverse debugging with CLion and undo software. And the last question on debugger is about cross-language debug support. And Eldar, maybe you can share our plans here.
Yeah, one quick words on CUDA debugger. So as far as I understand, so right now it's not that different in terms of integration. So I might be mistaken. So it's worth checking, and we are going to check that with the NVIDIA guys. But as far as I understand right now, it's basically GDB with some extensions specific to debugging, seamless debugging the GPU code. We do have some issues with this integration indeed. So there, I can recall some tickets in our bug tracker. We haven't unfortunately managed to investigate it further yet. So let's wait for some. Let's wait. So we will definitely be back to that, and hopefully there will be an easy fix for that. And so regarding the cross-debugging feature, there actually was an internal prototype created by 2 internship students. it was a Python cross debugger that allows you to step into, for example, from Python into C, C++ native codes at some breakpoints in both languages, and so on and so forth. Unfortunately, we haven't managed to integrate it to the IDE, but we do still have some plans on doing that. Maybe not the highest priority though. And there's actually also another plan to try create a JVM cross debugger. So there is, as you probably might know, that there is a dedicated team at JetBrains working on the JVM, our own Java runtime. So they do work a lot with the native codes, and it's just like another example of dog fooding that we want to try create some feature that our own colleagues would use. And it actually does seem to be less complicated than Python. So we haven't investigated it like deeply, but at the first glance, the Python prototype that we have already, it was more complicated to implement. So hopefully we'll create the Java debugger as well, and manage to integrate the Python one too. So that's
Thank you, Dar, for sharing these exciting plans with everyone. So, and now we're moving further to the remote development, probably one of the most useful and popular feature in the current world circumstances. So, I would like to pass to Vasya and ask him to make a short demo of the remote development capabilities. I will share the screen with you.
That's a simple application which just prints your operation system name. Here we works with Sigwin toolchain. You can see. Let's try to run our application. And we can see that currently our operation system is Windows, and we work with Sigwin toolchain. Now let's try to add remote toolchain. Let's go to toolchain panel. Let's press plus button, add a new remote toolchain. Let's rename it. For example, it will be remote Linux. Then we have to select proper credentials, or you can add the new one. Now we can see that we are connected, and we successfully detect remote CMake. Also, please note that you can browse remote file system, and for example, to select the custom CMake binary. Let's do that. And I suppose that's basically it with configuring remote toolchain. So let's go now to CMake section, and let's add a new CMake profile and map it to our remote Linux remote host toolchain, and press OK button. So what's going on now? We can see reloading CMake project progress indicator, and let me briefly describe what's going on under the hood. First of all, we upload the sources of our project to remote host. Then we run remote CMake, analyze its output, and collect remote compiler information. And then after that, we download remote header routes to the local machine. And then we are indexing them. You can see it here, and building symbols. So yes, we're ready. After the process, you can select your remote CMake profile, and please note that right now the follow branch of the code becomes active. And the main idea that when you work with a remote toolchain, the whole experience and the whole code assistant have to be absolutely the same as you work locally. For example, code completion have to work, and for example, navigation have to work. Yes, for example, we navigate to the header file, and as you can see, the path of the header is a little bit strange. Yes, that's because we download that header from the remote host and cache it. For example, we can switch back to CLion toolchain and go to the same header. And now, as you can see, we go to the different header because that's different toolchain, different environment. Okay, let's switch back to remote profile, remote toolchain, and try to run our application. So what's going on? First of all, we built our application remotely and then run remotely. In this case, we can see that our operation system is Linux, and we can see some details about Linux. And I suppose also, of course, we can debug our application. We can run debugger and stop on the breakpoint. And yeah, that's it with debugger. And the last, I suppose, interesting part, what's going on with in case we edit in a local file. The answer is quite obvious. We just sync our local sources to remote host, but let's check it. We can go to remote host, open remote terminal, go to our remote part of the projects. Let's check that it's our project. Yes, that's correct. And now we can, for example, open main CPP. Okay. And for example, let's add something like doxygen command and some description, for example. And let's check it on remote part. Yeah, here we can see our command. I suppose that's it with basic demo. Now we can move to the question, bugs, and of course, performance problems.
Yes, Vasya, so maybe you can address one question from the pane asking about the excluded project files. So is it possible to add excluded project files to excluded section in mapping? This is crucial when building remotely only a part of a large project.
Yes, of course, you can do that. For example, go to development section and there is a special tab when you can add an exclude path. Yes, you can do that.
Okay, thank you. The next question is about supporting Git copy when working with remote machines.
The question about .git directory. Of course, we can upload .git directory, but we do not do it intentionally. If you wish, you could change these settings and we upload .git directory to remote machine. But the most interesting part, why do we prohibit uploading code directory by default? The first reason, because .git directory might be really huge and it's not required for our correct work on remote machine. And the second one is that, and that's most important problem, that at the moment we have no remote VCS support, and it means that we cannot correctly work with your remote .git directory unlike the local one.
Yeah, thank you, Vasya. I suggest we proceed with the Docker demo now. So I will pass to Phil to show you a short demo, and then we'll discuss the Docker support. So Phil, I'm making you a presenter now.
So hopefully my audio is going to be in sync. It's a shame that Vasil's is a bit out of sync because it's an excellent demo. I'm going to show some of the remote features again anyway, in a slightly abridged format. So if it didn't make sense the first time around, maybe it will now. But we're going to be talking about Docker. I know there's a few questions on Docker, and we're not going to cover all of them in this demo, but maybe that'll lead into it. To start with, I've got this blog post up. This is something I did earlier this year, and there's an accompanying video with this demo. What I'm going to show now is an abridged version of that demo. If you want to go into it a bit more, go to this, find this blog post, just search for Docker CLion, look for videos, you'll find it very easily. Now in there, I do mention that we have a repo that Vasily, who you just heard, set up some time ago. Now we did this as a sort of a workaround really, because we don't have first-class support just yet for working with Docker in CLion. But what you can do is you can set it up as a remote host. So that's what we're going to do. Now the Docker file, looking at it in GitHub here, but I'll show it to you now in CLion. I have this project here that we're going to be using. I've got that locally, so you'll see it in action in a moment. Now, if you've never used Docker before, you can actually still get up and running with these instructions. The Docker commands you'll need are at the top. The instructions for setting Docker up itself are a little bit more involved. It's actually not too bad. On the Docker site, you can get all the full instructions. I'll go into this file a little moment in a bit more detail, but I just want to come to my little sample application. This is even simpler than Vas's one, but doing a very similar thing, it's just printing out the host name. So just using POSIX get host name. That's all it's doing. So if I just run that now, just running locally, just prints out the host name of my machine that I'm presenting from. Nothing too fancy there. So what we want to do, first of all, is actually set up this Docker image. So we'll go back to that Docker file. Now Docker as a container technology, it's like a lightweight virtual machine. So it's actually starting with a base image that's running on a particular operating system, in this case Ubuntu. If you've not used Docker before, just use this Docker file. If you're familiar with it, then obviously you can customize this as much as you want, but do use this as a reference. Starting with that base image, we just install all of our dependencies, such as the compilers, debuggers, CMake, that sort of thing. Apparently Build Essential does include most of those anyway, so you may be able to pare that down a bit, but regardless, we're just using apt-get in this case to install those. Then it will set up an SSH config, because that's how we're going to connect into the Docker container, just over SSH, using exactly the same remote development features that Vasa just showed you. We just add a user. That's the actual username and password password and user, that this particular file was set up. So obviously you can change that to however you want, and if you want to get more involved, you can probably set that up somewhere else. But for most purposes, that's not going to matter too much. And finally, it just starts the SSH daemon. So that's what this Docker file does. There's a little bit more to it in terms of how that works and how that does so in a very performant way, which we're not going to get into now. What I want to do is just jump straight to, first of all, building that Docker image. That first command line there, if I switch to the terminal down the bottom, I can run that. If I just select it properly, there we go. So that's just going to build that image. Now, I already had it installed before. Although I removed it, it's still in the cache. So that was pretty much instant. First time you do it in practice, it's going to take a few minutes to download and install that, which is not bad considering it's giving you Ubuntu and all of those dependencies. But yeah, it will still take a couple of minutes. So it's a good job we're cached here. The next line I want to run will now run that Docker image. And you can see it's given us a hash back. That's the hash of the running image. Like I do Docker PS, you can see it running there now. It's been up for 7 seconds. And we can use that name if we want to stop it or remove it. The third line there, we need to do this to remove any previous instances of the SSH keys, because we are using, because we're going to be reusing this port potentially many times, as if it's coming from different hosts. So it can get a bit confused if you don't clear these out. So in this case, it's cleared out. Existing keys, it may say the first time you run it that there were no keys. That's fine as well. Just an extra precautionary step. So now we've got a Docker container up and running with all our toolchain that we want. So if we set up different compilers in here, we can actually have parallel Docker images with different toolchains, and that can be really useful. So at this point, if we go to settings in our toolchains, and again, we saw this in Vasa's demo, we can add a remote host. And I'm going to call this Docker just so I can distinguish it. Again, it can be really useful to give them different names if you're setting up multiple toolchains concurrently. And we use this new feature in our SSH configs where we can actually reuse earlier credentials that have been saved. So I already had this saved, but that's the port that I used in the Docker file, that username and password. I can just test that to show that it can connect in via SSH okay. And then it goes away, and again, exactly as before with full remote development, it's going to detect that tool chain because it's all installed to the default locations. That should detect everything. And there we go. And then we want to add a CMake profile that we can use. I'll make this debug. And using that Docker toolchain. And that's it. Obviously, if you have other settings you want, you can change them, but that's all we need at a minimum. That's now going to go away and, again, as before, copy those files, our source files, into the container. Now, this is a step that some people would rather was more efficient, because if you have a large project, that can take a while to sync in, especially the first time. Some people, as a workaround, have been able to have a mounted volume in the container, just map back to where their source files are, and that can work, but we're not supporting that at the moment. There are some issues with it. I think somebody in the Q&A was asking about that. So we don't currently have a solution for making that work fully. I think that's something we're going to be looking at in the future to provide a more fully fledged support. Maybe Vasa will talk about that a bit more afterwards. But this works. For this small project, it doesn't take very long. We're already set up and running. So I can now select that Docker run config, can build it. And you can see it's just created that in a temp directory. in the Docker container. If I run that, you can see the host name. That's actually, if we go back to the Docker commands, that was the first part of the hash that we saw. There are ways to change our host name if you want, but this was just for the purpose of the demo. So I think that's all I had to demo here. I feel like I missed something somewhere, but I suppose we'll pick them up in the questions. So
yeah,
we're going to keep my screen open.
Phil.
Yeah.
Yeah, let's keep your screen, and I will try to address a few questions from remote. So just since Vasil unfortunately has some delays in connection, I will just try to do it on my own. So first of all, like what Phil just demoed was the Docker support, but you might notice that it's not like some built-in, or maybe you wish for some more native Docker support, and we definitely considering this right now. So we're going to start work on like native Docker support in upcoming release, but we can't promise that it will be ready by the time the 2020.2 is released. So we'll see how it goes. So possibly in first versions, we'll still run some processes via the SSH, and we plan to eliminate some unnecessary file system synchronization and some other things which we still have to consider and think about a proper like technical solution. So it's a big task, but I just want to assure everyone that we're on it. So we are working on it right now, and we're thinking about the possible solutions here. Also, in the questions pane in the registration form, there was a question about the VS Code-like remote development approach. Like you might notice here that what we do is that we take the project from the local host, from the local host, synchronize it to the remote host, and synchronize the headers back to the local host to avoid the long resolve process. But there is another approach used by VS Code when your local machine is something like a lightweight agent and everything is happened on the remote machine. So we definitely think this way in JetBrains, not only in CLion, but in all other IDEs, and we think about possible solutions here. There are still lots of questions, so I can't promise you any ready-to-go solution anytime soon, but I just want to assure you that we're working on it and trying different prototypes inside the company, and I really hope that we'll have something like that in the nearest future. And also there were a few questions on various remote development performance issues, which are definitely there because we include lots of synchronization steps, and like, for example, reloading CMake project step is also not just running remote CMake, but also includes like processing of the CMake output, collecting compiler information, and other things which are done in the background. So, and that's why these steps actually consume so much time in case of remote, but we plan to optimize them. So briefly, if you want to know what we're going to do here, so we plan to avoid unnecessary transfers of the build artifacts to the local machines. So we plan to improve the speed for the file transfer and like optimize some other processes that are included in these synchronization steps. So we'll definitely share the list of next steps and issues when we do a dedicated blog post with the recording, so you can find them later in the blog. And I think that's mostly it regarding the remote. So we're coming next to the next part. I will grab the screen from Phil now. Yes, so that was about remote, and now we're coming to embedded development and a very exciting Arduino demo. So I'm passing to Ilya now. Ilya, please unmute, and I'm making you a presenter.
So, hello everybody, my name is Ilya. I'm responsible for embedded stuff here. And what I'm going to show you today, it's a very expected feature, not might be feature, but approach to run Arduino projects with CLion. So, first of all, you can find an Arduino compatible board here in the video. And a very simple example of Arduino sketch, just standard blinking example. So let's check if it works or not. Now it compiles, it flashes into Arduino, and it started blinking. So we have a working example in Arduino. Let's try to reproduce the same stuff in CLion. First of all, there are at least two approaches how to do that. Recently, we released a plugin to support the platform.io environment. You might find it in the internet, platform.io.org. This is a really big. It supports a lot of different boards, including Arduinos. And now we can use it with CLion. What we do need for this, we do just need to install the platform.io plugin. And here it is. So let's try to use it. So I just create a new project of type platform.io. And then, so of course, I have this platform.io installed before. Now I need to find my board here in the list. Sorry, Arduino Uno. Here it is. Framework is Arduino. Let's just create a project. Now platform.io does it's some internal stuff, including downloading the tools. It might take some time, but of course I have that stuff already downloaded. So now we have a stub of the project with an empty C file. Let's put Arduino code here. First of all, we need to rename the file because Arduino code is more like C++ rather than C. So let's make it C++. Next, we need to let CLion know that project structure was changed. Now we can just copy the code from here to CLion. And of course, we have some red diagnostics because in Arduino we use special version of C++ like named wiring. And Arduino IDE makes some pre-processing of the sources before compiling. Let's do the same stuff manually. Basically, we just need to include, in this case, only one H file. So now it looks working. Let's change numbers a little bit to see that our blinking is a bit different, has a bit different pattern. And next we need to select upload target because debug is not available on Arduino, and just run it. And Platform.io does everything for us, including flashing. And now we have our firmware compiled in CLion using Platform.io compilers and flash it automatically to the our Arduino board. So this is the basic approach. On the same time, some people does not accept this because Arduino is a bit like for amateurs, not like for profis. And I can show you that we can run the same project using just a normal AVR-C compiler downloaded from Microchip website. I have a project already done. Let me just open it. So in this case, we need to do a little bit more of preparation. First of all, we need to install CLion and build environment MinGV for it, and also toolchain from Microchip and our Jude, which is like very familiar to people doing stuff with Arduino. So next we need to set up So of course, we need to write our code, set up tool chains. Let me show how it's done. So we have the tool chain for AVR here, and to make profile using it here. So, and then next thing to do, I packed this running of AVR to flash our Arduino just to a custom target in CMake. So here it is, and we need to just to manually set the path to AVR utility and the name of COM port connected to the Arduino. Of course, Arduino IDE does it for us, but in CLion we have to do it manually. Okay, let's go back to the code. So here we have another pattern to blink, and we just can run it on the chip. In this case, we need to press flash button rather than run or debug. Nothing happens, and now we have another pattern blinking. Now that's it. So apparently, we are able to use both Arduino or AVRC on with CLion. Yeah. Thanks for watching.
Thank you, Ilya, for this amazing demo. And I would love to ask you a few questions from our audience. So first of all is maybe you can share our plans regarding the support for other microchips like Cortex-M-based chips or some others. So what we're going to do in this direction.
Okay, about other chip support. So basically, we don't focus on like some particular chip to support. We just try to cover as much as possible. So at the moment, we definitely can run any stuff for Cortex-M series. We can run stuff for AVR, as you can see. I think we can run for MIPS-based chips. At least I heard the feedback from people they were able to run. So basically, our requirement is to have a compiler toolchain for target platform, preferably JCC. For now, if there is a JCC, more or less modern version for your target platform, it should work in CLion. Recently, we also released support for IR compiler. At the moment, it's verified only for IRM chips, but anyway, it works. And we are gonna go further with that. What else do we have in our plans? Trace support. It's very demanded feature, but we need to do some research because it depends very much on the hardware we are using. So we need to find the common approach how to run traces, hardware traces. What next? Data analysis support. For instance, if a bare metal device collects some data, I don't know, some real-time data or final or whatever, and then we wanna process this data on a host machine, just to analyze which kind of data, what happens there in real time. So this is in our plans. Also, we are going to support other compilers like IRM, or might be something else, but there might be some delays with that related to.
And what about the debugger support, like some circuit debuggers?
Sorry, which kind of debugger?
Like some specific debugger support, like some chips debuggers. Anything specific?
Well, at the moment we support JDB. If there is a JDB and JDB server for target platform, everything should work. Some specific, well, there are some plans, but I'm not sure if we can really disclose that at the moment. We can't really promise anything. But yeah, if general approach is almost as with tool chains. If there is a JDB server and JDB for target platform, it should work already. And yeah, probably something CUDA debugger might be also for embedded video systems, but yeah, I don't know at the moment.
Okay,
what
thank
else?
you. And maybe just the last question here regarding what we have and what are our plans is what about improvements to debugging experience for embedded targets in terms of memory view, peripheral views? Can you say a few words on it?
Yeah, okay. So at the moment we have some kind of a memory view. It's not really nice at the moment, but it kind of could be used a little bit, and we are going to improve that as soon as possible. The same for disassembly view, and about peripheral view, it's already implemented. Actually, I can show you a demo. Just let me switch boards. This is STM32, and I have a project for this. So yeah, that's a project with a breakpoint. And when we reach the breakpoint, we can just watch the set the peripheral view by loading standard SVG files and filtering required devices, in this case only GPIO, and then watch the changes in the registers. If I go to here, you can find that OGR register is always changing because of blinking LED. OGR 8 is always changing. So this stuff is already done, just use it. What else? Semi-hosting. There were a bunch of questions about semi-hosting. Basically, you can already use it. Unfortunately, this is not really nice supported yet. If you use Segger, for instance, you can use semi-hosting with Segger utilities. Probably I will write some blog post how to use that stuff. And if you use OpenOCD, which is kind of a first thing which we supported, semi-hosting works there as well. You need just to put a setting to .jdb init file for it, but it's declared to be really, really slow, and it is really slow, so almost useless. But yeah, in future, yes, it's in my plan to do some support for semi-hosting stuff like that. Yeah.
Thank you, Ilya, for answering these questions. So I think we'll move forward from this amazing demo. So I'll grab your screen now. So that was the embedded part, and now we're moving forward to everything which is left now. So we'll very briefly answer the question on CTest support and then go to the others. So Alexey, I will pass the screen to you so that you can show the answer.
So, okay, I'm ready.
Yes, we can see your screen.
Okay. Thank you. I'm Alexey Utkin. So I'm responsible for unit tests framework support in CLion. So, and one of the questions that we get on the board is about the CTest support. In short, we don't plan to extend CTest support in the near future. The reason is that CTest pretty much duplicates the functionality of CLion configuration. But if you have a project with deep integration with CTest, you can incorporate CTest to CLion configuration step by step. Let me show. So, for example, here we can start editing new configuration and add new CMake application. Just get the name, let's it call CTests. And to make it available, all executable for a test execution, all test binary, we are selecting all target. And what is new, now we can select execution for a configuration, not from the target of CMake, but any executable, for example, from CMake installation. Let's do it. The next things to do is appoint the working directory where we would like to run the CTests. Let's use for this purpose the macro where the binary is generated. Just prepare our configuration and just start running it. Here we are. So if you have CTest configured in your CMake file, CMake list file, you are able to pass all tests what is described where. As you see here, all functionality which is related with changing the run configuration are supported automatically. For example, here I have configured release configuration for a Visual Studio instead of min.gw. Let's try it again. Here we are. As we can see here, the binary path was changed, so we really run test over the new binary, which is connected with compilation together with Visual Studio. Okay, let's try to do it together with CLion. And sorry, here we failed. What's the reason? The reason is that we see the we are trying to use CTest from CMake, which is not able to recognize CLion paths. How can we fix it? That's really easy. We just change the CTests, or better to prepare the new run configuration together with CTest, which we take from a CLion installation. Just make a copy and let's change our CMake, our CTest to CLion. Here we are. Let's try to run CLion together with appropriate executable, and everything works as expected. So potentially we would like to so you see that we just run CTest without any pretty test result tree, and a pain point here is that opposite to CMake, we are not providing the CTest together with CLion from the box. You need a separate installation. Potentially, we can customize the CTest not running. For example, here we have one failed test. We have no test result tree, so opposite to test result what we get from officially supported test framework, we can't rerun failed test and some nice functionality with history here, but nothing prevents us, for example, to customize our run for particular tests, for example, like this. So limit our execution only by test, but started from test in file. Can we do it? Yes, we can. So it is not native, but some limited support for it. CTest, it's provide you an ability to run your environment and everything you like together with CTest. What is concerning the common overview about the test framework, we have integrated support for a Google test from very old version, which started from 2005 years, and the latest one, which is 1.10, and it has essential changes in comparison with the previous one. We have Catch framework support for the first and second versions. We have Boost test support starting from version 1.61, which have an additional setup params to the latest version. Currently, we have no plan to support any additional frameworks, but there is nothing that prevents us from this. In the nearest release, we are planning to check our support over the cutting-edge version of each framework that is in the list and increase the CLion performance. As you know now, for example, we already isolate some part of application program interface, which is using for integration our test support together with project model. Here you can find that all our framework support for tests are isolated in plugins. And for example, if you have some performance issues, for example, you can disable some plugin which is not used by your application, and maybe you can improve your performance. That's practically all. So if you have a question, please ask. Oh, you can
thank you, Alexei, for this. Yeah, thank you for these great performance tips. And I definitely see some interest in your CTest demo. Probably we need to do a separate blog post on how to work with CTests right now. So maybe we'll consider that for the future. So I would like to grab your screen now and follow up with the rest of the questions which we have briefly. So what do we still have here? Like a question on C++ CLI support, if we plan to add it to CLion. So for now, we don't plan to do that. So the C++ CLI, if you don't know, is a bridge between C++ and C#, and it's nicely supported in ReSharper C++, which probably is more native environment for this kind of development. Regarding the Rust support, so we have the IntelliJ Rust plugin, and there was a question if we plan to release the separate Rust IDE. So for now, we don't have these plans, so we don't see this demand. So we have IntelliJ Rust plugin working in CLion and IntelliJ IDE and other tools, and like we've just recently separated the debugger part so that the debugger will also be possible if you're using IntelliJ Rust in IntelliJ IDE. Also, there was a question about the Unreal Engine support. So as I mentioned previously, we just opened the public preview for Rider for Unreal Engine with some very specific Unreal Engine support and integration with Unreal Editor. So these features might later come to CLion as well, but as we see it now, Rider will be our main offer for the game dev, so we'll probably be working in Rider in that direction. The question regarding the community version, if we plan it, so for now we don't have such plans. So we have, as you might know, we have free versions for free licenses for students. We have some discounts for startups. So the community version is not planned for now. Also, there was a question on the plugin development. So here you can see the link to the SDK docs. So you can actually review them and check what's possible in terms of the API. So CLion is based on IntelliJ platform. So basically all the IntelliJ platform API is available. There are a few things not available in the public API, like project models and some maybe debugger specifics. But if you're interested in creating a plugin in that direction, just ping us and we'll try to help you with some things that are not publicly available, but we still can collaborate and help you with the plugin. Also, there were a few questions regarding on how to start with CLion, how to install it properly, some general tips on starting with the tool. So we didn't have enough time to cover that during the session, but I do recommend you go to the web help, which I showed you previously. So here you are, and you can find the quick start guide here, a very detailed guide on how to start with CLion, and also there are a few tips on how to install the CLion properly, what are the requirements. So just go through these pages and learn how you can start with CLion. And at the YouTube channel, you can find a CLion playlist, which includes quite many demos and videos, which you can also look through. And there are some basic demos. There are some demos on some particular features, so feel free to watch them and learn some new things about this CLion. Oh, there was a question on Conan used as a package manager and if we plan to integrate it. So the Conan team actually released some plugin for using Conan inside CLion, so you can check it in the plugin repository. And also there is a detailed blog post how to start with Conan in CLion in our blog, so just search for the blogs for it. And if you have interesting ideas on how to make the Conan plugin for CLion more rich and any ideas of the interesting features you would like to have there, please feel free to log them, for example, to our issue tracker, and we'll definitely pass it to the Conan team and try to work together with them to see if we can have them in this plugin. So I think that's mostly it for the day. So because we're nearly 2 hours on air, so I will just finish with a couple of pieces of useful information here. And just again, all the questions that are left unanswered, we'll handle them via email in the upcoming days. So make sure, just be sure we'll handle them. So you can learn more about CLion at jetbrains.com/CLion. You can follow us on Twitter and just go to the YouTube channel, find the CLion playlist to watch some CLion related demos. Subscribe to our blog, blog jetbrains.com/CLion. And if you have any question, just ping our support. Our support engineers will be happy to respond and help you with any issue you might have with CLion. So thank you for joining. Thank you for all your support and good comments. So stay home, stay safe, and hope the world is back to normal quite soon. And we really miss you all. So thank you all and bye.